Jai Hind all of you. So myself Jitendra Yadav. Today I am going to discuss about thermodynamics, which is running in second year mechanical branch. So our today's topic is basically basic concepts of thermodynamics. Okay. So we will discuss today the fundamentals or basic concepts of thermodynamics, which is very important for the thermodynamics as well as for next semester subjects like applied thermodynamics, RAC, power plant. So it is very important subject. So you can create first our basics or strong our basics, then we will proceed for next. So first today we want to discuss about the what is the meaning of thermodynamics. What is the meaning of thermodynamics? Okay. So in our engineering, every concept has a one meaning. So here we can see this thermodynamics is basically a joint of two words, which is thermo plus dynamics. Okay. So thermo means basically energy, and dynamics is basically motion or transfer. Okay, or transfer. Okay. So what kind of energy basically? Basically there are two types of energy. First is heat and work. Heat or work. Okay. In our thermodynamics, basically two types of energy we will discuss. First is heat and second one is work. Okay. So here we will study only the transformation of heat into the work or work into the heat. Okay. It means here we will study heat will transfer into work or vice versa. Okay. Heat will always transfer by virtue of temperature difference. Work, it may be mechanical work, it may be electrical work or some soft work or some other work. Okay. So here in this thermodynamics, we will study only transformation of heat into the work and work into the heat. Okay. So first we will discuss about the system. What is the meaning of system? Okay. So system basically a area or a space upon which focus or attention is concentrated. For example, if this is any kind of bulb and this is filament. Okay, this is basically what is this is bulb. So in bulb, by this filament the lights will emitted. Okay. So in this whole system, basically this filament is system. Okay. or in any class, the teacher is system, or anywhere where we can only concentrated or main part. Okay. So in this world, this filament is basically a system. Okay, or in some any device, in that device the main portion is suppose for a refrigerator or AC, the compressor is main system, because the whole working is only depend upon the compressor. If compressor is failed, then the system will not work. Okay. So system means only the main part of the device or anywhere. Okay. So first we will specify the system, and next one is surrounding. Surrounding. What is surrounding? Anything except the system, or everything external to the system is called surrounding. Okay. So for this example, here this glass is surrounding, or here this gases or some gases must be filled in between the near the filament. So this gas is also may be considered as surrounding. Okay. So surrounding means here suppose for example in classroom the teacher is system, then student, blackboard, chalk, duster, everything is surrounding. Okay. So system and surrounding will separated by one boundary. Suppose this is any boundary. Inside the boundary it is called control volume. Here this is system. Okay. And external to the system is called surrounding. Okay. So this is system and this is surrounding, or this system and surrounding will separated by one boundary, or inside the boundary is called control volume. Control volume. Okay. For example, this is any piston cylinder arrangement. Okay, this is any piston cylinder arrangement. Here the cylinder is filled up by any gas having pressure P, temperature T, volume V, density, enthalpy, entropy, blah blah things. Okay. So if this gas is system, then this piston cylinder, everything is surrounding. Everything is counted as surrounding. Okay. So this system, now third one is universe. Universe means system plus surrounding. Okay. System plus surrounding we can call as universe. Okay. Now the fourth one is types of system. Okay, there are basically three types of system. First one is closed system, second one is open system, and isolated system. Okay. Closed system, open system, and third one is isolated system. Okay. So here now we will discuss the closed system, open system and isolated system. Students, frankly speaking, these three things are very important for any numerical, because first we have to find out whether it is closed system or open system or isolated system. Then we will segregate what the formula we can use for the solve the problem. Okay. So first we will discuss about the closed system. Closed system. Okay. So as you are generally aware about the closed system, that in closed system no mass will transfer but energy can be transferred. Okay. Suppose for example this is any box or something having some gas and which is covered by any, which is covered totally. So but by in this system the energy can be transferred, energy can be transferred, but mass cannot be transferred, mass cannot be transferred, no mass transfer, no mass transfer, but energy can be transferred. Okay. So in basically in closed system energy can be transferred but mass cannot be transferred. Okay. Now second one is open system. Here by name we can judge that in open system there something will be transfer and mass may be transfer in open system. Okay, so in this mass as well as energy can be transfer. So in closed system and open system basically the difference by only the transfer of mass. In open system mass can be transferred, but in closed system mass cannot be transferred. Here we can see energy can be transferred in both the systems, energy can be transferred in both the systems. Okay. Energy can be transferred in closed system also, energy can be transferred in open system also, but only difference is due to mass transfer. In closed system mass cannot be transferred and in open system mass can be transferred. Now third one is isolated system. Now third one is isolated system. Isolated system. So what is basically the difference between open, closed and isolated system? Isolated means, as we can see by the virtue of name also, isolated means completely isolated, means there is no kind of transfer, neither mass nor energy, means mass as well as energy can not be transfer, cannot be transfer. It is called isolation. So these three things are very important to judge the types of system, because the concept of closed system, open system and isolated system are totally different. We cannot use the concept of closed system in open or open concept of open system in the closed or isolated. Okay, so first we have to judge the system, whether it is belong from closed system or open system or isolated system. This is our first step to solve any problem. Okay, the correct way to solve any problem is first we have to find out the types of system, whether it is closed system, open system or isolated system. In closed or open system, the basic difference is mass. In closed, there is no kind of mass transfer. In open, there is mass transfer. Okay. Okay. Now, next one is fifth, thermodynamic properties. Thermodynamic properties. Any measurable quantity is called thermodynamics property. Measurable means pressure, temperature, volume, which we can measure. Pressure we can measure, pressure we can measure by pressure gauge, temperature we can measure by thermometer, volume we can also calculate. So any measurable quantity is called thermodynamics properties, like temperature, pressure, volume, or anything that we can measure or calculate, that is called thermodynamics property. So in thermodynamics property, basically two types of thermodynamic properties. First is intensive properties, and second one is extensive properties. Extensive properties. Extensive properties. So as we can judge by the name of intensive property or extensive property. Intensive property means it is independent of mass. Extensive property means it is depend upon mass, independent of mass. Independent of mass. So when it is depend upon mass. Depend upon mass. Okay, then you can justify if the property which is depend upon mass, then it is called extensive property. If the property which does not depend upon mass, it is called intensive property. For example, density. The density is intensive property or extensive property. So density means density is basically independent of mass. It is basically intensive property. Okay, why it is intensive property? Because density is depend upon molecular attraction of force of body or system. By the formula, density is kg per meter cube, means mass upon volume. So here we can see density depend upon mass, but no, it depends upon intramolecular force or attractive force of the atoms or the molecules. For the example, if any body having less less attraction force between the molecules, and any body have strong, like ice having strong attractive force between the molecules. So we can see that the density is more have the body which has a strong molecular force. Okay, now next one is next one is homogeneous system. Homogeneous system. Homogeneous system. Homogeneous system is consisting of a single phase. Means homogeneous system is consisting of a single phase. Heterogeneous system. Heterogeneous system. Heterogeneous system is consisting more than one phase. Okay, this is basically the difference between the homogeneous system and heterogeneous system. It is basically made by one phase, one or single, and this is basically more than one phase, more than one phase. Okay, now next one is thermodynamic equilibrium. Thermodynamic equilibrium. In thermodynamic equilibrium, basically there are three types of equilibrium. Three types of equilibrium means mechanical equilibrium, chemical equilibrium, or thermal equilibrium. First one is mechanical equilibrium. Mechanical equilibrium, chemical equilibrium, and thermal equilibrium. So a system will called as a thermodynamic equilibrium which follow all three equilibrium: mechanical equilibrium, chemical equilibrium, or thermal equilibrium. Mechanical equilibrium means there is no kind of unbalanced force. Chemical equilibrium means there should be no kind of chemical reaction, and thermal equilibrium means their system must be in thermal equilibrium, or then we can say the whole system is called thermodynamic equilibrium. Okay, now the next topic is state. What is the meaning of state? Okay, so first we will justify, or we will find out the state of the system. State means suppose we have any system, having some pressure, temperature, volume, or any thermodynamic properties. Okay, it means there is any state, we'll call one, have pressure P1, temperature T1, volume V1, entropy S1, enthalpy H1, etc. And the system will goes to the second state. In second state, there are also some pressure P2, temperature, volume, entropy, enthalpy, or any measurable quantities. So this is one state and this is second state of system. Okay. Process. What is the meaning of process? Process means basically change of state. Here we can see at state 1 system having property P1, T1, V1, S1, H1, etc. At state 2, when the system goes to between 1 to 2, the properties having P2, T2, V2 and S2 or enthalpy. Okay. So this is called process. Okay. So process may be cyclic also. It may be cyclic process. Cyclic process. Cyclic process means suppose there is any state 1 and this is any state 2. ठीक है, forward path is this and backward path is this. This is suppose path A, this is suppose path B. This is called cyclic process. Means the returning path must be different from forwarding path. Okay, this if A is forward forwarding path of forwarding, then B is returning path, then B must be different from A. Okay, so this is called cyclic process. Okay, now next one is quasi-static process. Quasi-static process. Quasi-static process. What is the meaning of quasi-static process? Quasi, first we should know what is the meaning of quasi. Quasi means almost static process. ठीक है, suppose X is any thermodynamic property. ठीक है, and dx is change in thermodynamics property. Okay, so if dx tends to 0, then it is called quasi-static process. Means the difference between one state to the difference of thermodynamic properties between one state and two state is almost equal to 0. Means there is we can say that there is very minor difference between the two states. Okay, so this is basically the quasi-static process. For solving the problem, it is very important to justify whether it is a quasi-static process, reversible process or irreversible process. So next one is reversible process. Reversible process. So reversible process is also similar of quasi-static process. So only the difference, if X is any thermodynamics properties, then dx is change. So for any reversible process, dx must be 0. Dx must be 0 means there is no difference between two states. Okay, or if we can plot any graph between pressure and volume, and this is first state and this is second state. If P1 is pressure during forward direction or during forward, and P2 is pressure during backward direction. So P1 must be equal to P2 for the reversible process. Okay, next one is irreversible process. This reversible process and quasi-state, these two process basically ideal process. Okay, this is basically ideal process. Now next one is irreversible process. Irreversible process. Irreversible process is basically actual process. All process happening in this world is considered as a irreversible process, and here Reversible process and quasi-static process always present by continuous line. Always present by continuous line means between there is no discontinuity between initial and final point. Okay. Now for irreversible process is basically actual process. Okay. So representation of irreversible process is always by discontinuous line. This is 1, this is 2. Okay. So irreversible process is always shown by discontinuous line, because in irreversible process there is lot of discontinuity between the states. Now for the calculation purpose, basically the calculation is same for quasi-static and reversible process. Quasi-static and reversible process. Okay. So for any problem, first we have to find out the types of system, whether it is belongs from closed system, open system or isolated system. Then we have to find out the types of process, whether it is quasi-static process, reversible process or irreversible process. There are some basically clue given in maybe given in the problem, like if any system or is frictionless system. So frictionless system is basically ideal things. So any ideal things is considered as a quasi-static process or reversible process. Okay, any actual process is considered as a irreversible process. Okay, so I am stopping now. We will continue in next lecture. Thank you very much.